All right, here we go. We got a review of what we've done so far with systems of equations. And so we're going to start this review with just a different kind of question. Make sure that you understand what it's asking. And it says determine if the ordered pair is a solution of each system of equations. So what we're looking for is we have our two equations, we have our ordered pair, and we want to know if this is a solution or not. So there's a couple different ways that you can do this. You can go ahead and graph these two equations. You could go ahead and solve by setting them equal to each other. That's another way to do it and figure it out. Or you can go ahead and substitute each one into the equations. And that's what I want to show you today is, we've practiced solving for x and y and graphing them. This time when you're given the answer, just a quick substitution. So we start with our first equation. So instead of writing y, we're going to write 3 is equal to 2, and then in parentheses times 2 minus 1. 2 times 2 is 4, and so 3 does equal 3. So it works for my first equation. Now let's try the next equation. So again, I'm going to put 3 in for y, 2 in for x, rewrite the rest. I have 3 equals 3, and so it works, so I just write in a quick yes. And so we'll just do the second one next time I see you in class. Let's go ahead and practice solving by substitution. So what we're going to do is, even though you might want to do elimination method, since I am stating substitution, that's what I want to see work-wise. So what I'm going to do is I have to check and see, are either one of my equations have a variable by itself? And I do not. But I'm going to take that top equation. I'm going to take x plus 2y equal to 1, and I'm going to solve for x. So I'm going to subtract 2y on both sides. I have x is equal to negative 2y plus 1. Now by doing so, I can take this expression, negative 2y plus 1, and substitute it in for x of my second equation. So now I'm going to go ahead and do that. I'm going to rewrite that second equation. So it's going to be 2, and then instead of writing x, x is equal to negative 2y plus 1. Minus 8y equal to negative 1. So just rewriting the rest of that equation. Now I'm just going to go ahead and solve for y. So I get negative 4y plus 2 minus 8y equal to negative 1. So all I did was distribute that 2. Then I combine like terms, so negative 12y plus 2 is equal to negative 1. Then I just subtract 2 on each side. I get negative 12y is equal to negative 3. Divide both sides by negative 12. I get y is equal to, well, negative divided by negative is a positive. 3 over 12 simplifies to 1/4. Okay, and that's great. Now the next thing I'm going to do is substitute 1/4 in for x. Doesn't matter which equation you use. I'm going to go ahead and use the top one. So I'm going to maybe draw a little line, keep my work divided, rewrite that top equation. So x plus 2 times 1/4 is equal to 1. And so when I work this one out, 2 times 1/4 is 1/2. Oops, I meant to write a plus. Equal to 1. Subtract 1/2 from both sides. And so x is equal to 1/2. My final answer, I'll go ahead and write down that it is one solution at the ordered pair 1/2, 1/4. Okay, perfect. Now the other substitution problem, we'll work it out together in class. Okay, so we'll practice that one together. Let's go ahead and practice elimination real quick. So when we practice this elimination, what we're going to do is multiply to create opposites. So I have a 5x and a 3x, a negative 4y, and a positive 3y. So I'm just going to go ahead and create opposites with my y variables, just because I already have the signs set up. I'm going to go ahead and multiply my first equation by 3, my next equation by 4. My common factor is going to be 12, so I'm trying to get 12y. So when I rewrite that first equation, remember you're going to take that 3 and multiply by every term in that equation. So we get 15x minus 12y is equal to 42. So again, 3 times each term. Then I'm going to do the same thing. 4 times 3x is 12x. 4 times 3y is 12y. And 4 times 3 is 12. So every term, again, multiplied by 4. Now I have my opposites, and so I can combine my two equations, add that up. When I add that up, I get 27x equal to 54. Divide both sides by 27, and I have x is equal to 2. And so from here, all I need to do is solve for y. Go back and pick one of your original equations. When I pick one of my original equations, I'll just pick the second one. That looks a little bit easier to me. So I'm going to go ahead and do 3 times 2 plus 3y is equal to 3. So just rewriting it, substituting 2 in for x. 6 plus 3y is equal to 3. Subtract both sides by 6. We get 3y is equal to negative 3. Divide both sides by 3, and y is equal to negative 1. And so my final answer, again, is one solution at the ordered pair to negative 1. Okay? All right, that's it for this front side. Let's flip it over to the back. So on the back, let's go ahead. I have two story problems. We'll do this first one together right now. So we'll talk about Mary's age is 5 times Joyce's age. The sum of their ages is 18. How old is each? So first we have to label our variables. And so when I label my variables, I have, I'm going to use x equals, y equals. And the two things that I'm trying to figure out is Mary's age and Joyce's age. So we'll go ahead and label x as Mary's age and y is Joyce's age. And so from here, what I'm going to do is create an equation from the information that they gave me. The first bit of information that I can create an equation with is Mary's age is 5 times Joyce's. So it's really, when we talk about Mary's age, I can label that as x. Is tends to be an equal sign, not always, but in this case it will be 5 times Joyce's age. So 5 times, and then y is Joyce's age. So that's my first equation. Then they say the sum of their ages is 18. So x plus y is 18. So that's Mary plus Joyce together is 18. I have my system of equations. Now what we're going to do here is figure out, what do you think is the easiest method to solve this equation or this system? And substitution, I think, will be the easiest for figuring out our variables. And so by substitution method, I'm going to go ahead and rewrite my second equation, but putting 5y in for x. So that's going to look like 5y plus y equals 18. 6y is equal to 18, y is equal to 3. And so to solve for x, I'm going to take that top equation. X is equal to 5 times 3, since y is 3. X is equal to 15. And so the last thing I can do is state that Mary's age is 15, and then Joyce's age is 3. All right. Hey, that's it for these notes. We'll finish the rest up next time I see you in class.